Hey, welcome back. This is Professor Roldan with worksheet number 2 for Geometry 8.1. Okay, so we're continuing 8.1 with some new concepts here. We mentioned a few of these in class, but let's go ahead and complete our workbook with some definitions. So let's get started. So first of all, we have parallel lines. And they basically they're basically lines in the same plane and if they're lines in the same plane, these lines never intersect. And the symbol I'm going to use for parallel would be these little arrows here, okay? And in Algebra 1, we mentioned parallel lines in the coordinate plane, meaning that how can they never intersect is because they have the same slopes. Okay, it's that same incline or angle, and they never intersect because they have the same slopes. So that's parallel lines. Now we're going to be using that concept to talk about a transversal in a minute. So let's just continue with skew lines. So skew lines, these are lines, so this in different planes. So parallel lines are in the same plane, skew lines are in different planes that never intersect. How is that possible? Well, the only way I can really explain that is in a picture, and it has to be three-dimensional. So let me illustrate let's see here. So here's a rectangular prism, and we have a line, let's say this line right here, and this line right here is in a totally different plane. So it looks like they intersect on this piece of paper, but if you look at the dimensions, since it's three-dimensional, those will not intersect. Okay, they will miss each other. All right, so that's just skew lines. Let's talk about alternate interior, alternate exterior angles, and corresponding angles. So now we're going to switch over to, okay, what happens if I take the parallel lines and I draw what's called a transversal? It's basically a line that's going to intersect the parallel lines, okay? So now we can see that we have a scenario of two groups, one up here, another group down here of angles. So now let's talk about the definitions of some of these angles. Okay, so alternate interior angles, just as the name suggests, is that they are, well, let's take a look at the difference between interior and exterior. So the angles I'm referring to when we say interior, okay, that's going to be in the interior of the parallel lines. Okay, so let's just say, so there's the word in, so this is going to be inside. That's in here. Okay, that's the interior angles. All the angles that are, so there's 4 angles in here. We have 3, 4, 5, and 6. Those 4 are interior. They're inside the parallel lines. And then when we mention the word exterior, so when we mention the word exterior, we're talking about the opposite. So basically, exterior, X meaning outside. So those are the angles out here. Okay, so in this case we have angles 1 and 2 are exterior, and angles 7 and 8 are exterior. Okay, so now you have an idea what I mean by these 2 words. So if I say alternate interior, so these are interior angles. So these are interior angles on opposite sides of the transversal. Okay? Opposite sides of the transversal. So you can also say opposite inside. Okay? Opposite inside. Let's take a look at those. So angle 3 and angle 6, as you can see, they're inside and they're opposite of each other. They alternate. Okay? And then 4 and 5 are also alternate interior angles. So let's put that down here. So angle 3 and angle 6 are an example. Another example would be 4 and angle 5. Okay. Now let's take a look at the alternate exterior angles. So the alternate exterior angles would be outside angles that alternate. So that would be like 1 and 8. And also 2 and 7. Okay. So we're going to call those exterior angles. On opposite sides of the transversal. Okay. And some examples that I just mentioned were angle 1 and angle 8. Angle 2 and angle 7. Okay. All right. So now let's take a look at corresponding angles. So corresponding angles, basically, they're in the same position in both groups. So for example, this one up here, so here's a group and here's a group. And if you look, let's say out of the four, so we have top left, okay, top right, bottom left, and bottom right. So each of the four angles has like a little spot of their that corresponds to the same spot or location in the bottom group, in group number 2. So that would be like top left and top left, 1 and 5, those are called corresponding. They correspond to each other. They're both in the top left position. Another example would be bottom right. Bottom right would be 4, and bottom right over here would be 8, so on and so forth, okay? So we can go ahead and call corresponding angles are angles in the same position in both groups of angles, okay? So again, group 1, group 2, okay? All right, so some examples of those would be like angle 1, and angle 5, angle 4, and angle 8. So we could actually get more, but those two examples are enough for now. So let's go ahead and let's just mention why do we need to know these particular vocab words with these relationships? Well, the reason is because these three vocab words here, or these 3 titles for these relationships, alternate interior angles, alternate exterior angles, and corresponding angles, actually, they all have the same characteristic, okay? The same exact characteristic, and that characteristic or relationship is, so let's say angle 3 and angle 6, for example, the relationship is, for all of these, that they have the same measure. And if they have the same measure, that basically means they're congruent, okay? So angles 1 and 8, because they are alternate exterior angles, they are congruent as well. Okay, so that's pretty much what you have to remember about these angles. Okay, not only the title, so you kind of know what's going on, but if the question is asking for it, but basically, once you find them, they do have the same measure, okay? And that's true for all 3 of those. Okay, so to summarize, angle 3 and angle 6, congruent. Angle 1 and angle 8, congruent. Angle 1 and angle 5, congruent. Okay, that's the reason why we're even talking about this right now. I just wanted to provide one extra relationship, and that relationship, or that title, is called same side. So this is an extra. Same side interior angles. Okay. Same side interior angles would be like 4. This is interior. And then the other angle on the same side would be 6. So same side interior angles. The postulate is actually going to say that same side interior angles, example, angle 4 and angle 6 are supplementary. In other words, they add up to 180. Okay, so that's just a little extra one. You can probably bet that this is going to be on a notebook check. So make sure you're watching this video. All right, well, let's go ahead and start applying some of these concepts to finding angles on the next page. Okay, let's take a look at page number 2 and worksheet number 2. And we're looking at parallel lines cut by a transversal, creating 4 groups. Okay, so the one clue that you're given, and with this one clue, we are going to fill out the rest of these. Okay, so the measure of angle 3, since these are vertical angles, that's going to be the same thing. So this is going to be 135. Okay. Okay, the measure of angle 4. Well, those are alternate interior angles, so those are congruent. So this 135 is the same thing right here. Or we could actually say that this top left corresponds with this top left. So either way, it's going to be 135 as well. Okay, the measure of angle 2. Well, the measure of angle 2 is supplementary right here. This is a straight angle. Or you can look at it this way. It doesn't really matter. Either way, it's 180 minus 135 to give us 45 degrees. Okay, and if this is 45 degrees, then angle 5, these are alternating interior angles, so that's also 45. And then if we know this is 45, then we look across, those are vertical angles, so that's also 45. And then it's asking for angle 1, and angle 1 is top right, and so is angle 5. Those are corresponding, and that's also 45. Okay, so this is how we apply our knowledge of those three theorems or vocab words that we mentioned. Also, the extra one that I mentioned basically talks about same side interior angles right here are supplementary, so those should add up to 180 as well. Okay, so the next group you will do in class And let's go to the next page. And now let's use our knowledge to solve equations. So again, I'm going to be doing the odds here. And so number 13 says, find the value of x. So this time we don't need to actually get the angle. We just want to find the value of x. So we know that these angles make a straight angle. So this is a supplementary relationship. Okay, so nothing really new there. So 14x plus 20 plus the other angle, 2x, is going to equal 180. And we're going to go ahead and combine like terms. Draw these two here. Then we solve for x, so that means we're going to subtract the 20 from both sides. And then we're going to divide by 16. So x is 10. Okay, so this is number 13. Let's take a look at 15. Is there a relationship between top left and bottom left? No, there's nothing congruent about those two, like we mentioned in the other page. But x and this spot, those are two bottom left spots. So if we just do a quick subtraction of 180 minus 120, that's going to give us 60. So that's 60 there. And because these are corresponding angles, then we know that x is 60. Okay, let's go to number 17. 17, the relationship is vertical. Wait, I forgot to put, these are corresponding. Okay, and these two are vertical, so we know x is 32 as well. And the 17, these are alternating interior angles. And since they're alternate interior angles, remember that we know that they are congruent. And since they are congruent, so depending on how you write this, 6x minus 8 equals 5x, is going to kind of determine how many steps it's going to take. So you want to get x's to one side, but I also want to have the numbers, negative 8 on a different side. So there's various ways to do this, but I'm going to go ahead, just for this example, to move the 6x to the right side by subtracting it. So now there's 0 on the left, leaving us to negative 8. 5 minus 6 is negative 1, or just negative x. So we're not quite done. We have negative x, and we need to get rid of the negative, and we can divide that negative out. So this is just showing you that sometimes, depending on how you did the problem, you may end up with a negative x, but you need to divide out the negative. And sometimes it can even be backwards, and that's okay. It's okay that x is on the right and 8 is on the left. It still means the same thing. If that bothers you for some reason, then you're allowed to just switch it up. Okay? But this is perfectly fine. Alright guys, that's it for 8.1. We did worksheet 1 and 2, and this video was just worksheet 2. And then in the next video, which is be 8.2, it's going to have about 4 worksheets that we need to go through. So it's going to take some time to get through that, and look for it in the next video. All right, bye-bye for now.